This video will explain an event control loop. Hello, I'm James Helfrich. There are four types of loops. There's a counter control loop, a collection control loop, a sentinel control loop, and an event control loop. This video will define event control loop, show you the two different decisions you make during an event control loop, and show you several examples of some. An event control loop is a loop that continues until a given event occurs. The number of repetitions is typically not known before the program starts. The controlling event could occur the first iteration of the loop or after a million iterations. So here's a flowchart representing an event control loop. You'll notice there's always exactly two parts. The first part is the controlling expression. All event control loops are governed by a Boolean expression. The second part is the loop body, what happens every iteration. Sometimes we can go into the loop 0 times, sometimes many times. We don't know ahead of time. The controlling expression will tell us how many times the expression gets evaluated. So let's take a look at these two in detail. So the first, all event control loops are governed by a Boolean expression. In just about every programming language, true means the loop is a continue and false means the loop is finished. For an example, I have this Java program and I want to prompt the user for their age. Well, as long as the age is greater than 115 or the age is less than 0, I'm going to prompt the user again and again and again. So this Boolean expression completely controls how many iterations I go. So a couple best practices. First of all, we want to simplify the Boolean expression as much as possible because it will get executed multiple times. And second of all, predicates or functions returning Booleans called from a loop controlling expression should be extremely efficient. And once again, because they're going to get called many times. The second part is the loop body. Most event control loops have a loop body containing the code that will be executed at every iteration. This answers the question, what changes or could change every iteration? So back to our example before, our loop body is going to prompt the user for their age. So a best practice is to avoid unnecessary code in the loop body, once again, because it will get executed more than once. So let's look at an example. In this case, it will be Python. Once again, I'm going to have my function that's going to prompt the user for their age. Okay, so I'm going to have a variable called age, and I'm going to return that. Okay, so what I need to do is prompt the user for the age, and I'm going to keep iterating until I get a good answer. Okay, this is a pretty good first draft. But what am I going to do when the user types something in that's not a number? Well, I'm going to throw an exception, so I better catch that. Okay, I finished it. Now, we have a problem here. First of all, my controlling expression, while true, doesn't really tell me when I get to exit the loop. In fact, it doesn't tell me anything at all because the actual logic is embedded in here and as well as embedded here. In other words, the program is more complex than necessary. Now, observe, Python doesn't mind. It treats this just fine. It works, but what are we going to do when another developer comes in days, months, weeks later, and it's going to say, oh, hey, how am I going to modify this to add new functionality without breaking something? So we want to make sure that our implementation is straightforward and obvious as possible to minimize the chance of inadvertent errors. So I'm going to try this again. Okay, now I have exactly the same functionality, but my controlling Boolean expression is in the while loop where it should be, and the loop body is just a loop body. It doesn't control the loop. This makes the loop far more maintainable. You can learn more about event control loops in the event control section of the loop chapter of the software design textbook.